Based on the following trends, elements are arranged in periodic table. Valency, atomic size, and metallic and non-metallic properties. Let us discuss each trend elaborately. Valency. The valency of an element is determined by the number of valence electrons present in the outermost shell of its atom. Atomic size. Atomic size refers to the radius of an atom. The atomic size visualized as the distance between the center of the nucleus and the outermost shell of an isolated atom. The atomic radius of hydrogen atom is 37 picometer, 1 pm equals 10 to the power of minus 12 meters. Here note that valence means an electron, that is the highest occupied energy level of an atom, determine the properties of elements. And let us note that the distance between nucleus and outer shell can be defined as atomic radius. It has been represented in image by a thinner arrow. It is measured in A to power of 0, that is, angstrom. Atomic radius. The atomic radius decreases in moving from left to right along a period. This is due to an increase in nuclear charge which tends to pull the electrons closer to the nucleus and reduces the size of the atom. Example: to demonstrate atomic radius of an atom, the distance between nucleus and outer shell can be defined as atomic radius. It has been represented in image by a thinner arrow. It is measured in angstrom units. Decreasing of atomic radii from left to right in third period elements. Atomic radii of sodium is 186. Atomic radii of magnesium is 160. Atomic radii of aluminium is 143. Atomic radii of silicon is 118. Atomic radii of phosphorus is 110. Atomic radii of sulfur is 104. Atomic radii of chlorine is 99. As the atomic radii decreases from left to right in third period elements, then the size of atoms decreases. Trends in the modern periodic table. When coming to a group, the atomic radii increases downwards in each group. So, size increases down the group. The image shown on your screen is first group, alkali metal. Now let us move on to third trend, that is, metallic and non-metallic properties in brief. Metals. The elements which form positive ions by losing electrons, or donating electrons, are called metals. Metals are known as electropositive elements, because they can form positive ions by losing electrons. Examples are iron, aluminium, copper, mercury, zinc, tin, lead, gold, and platinum, etc. Non-metals. Elements which form negative ions by gaining electrons, or accepting electrons, are called non-metals. Non-metals are also known as electronegative elements, because they can form negative ions by gaining electrons. Though non-metals are small in number as compared to metals, but they play very important role in our daily life. Example are carbon, proteins, fats, carbohydrates. Oxygen. Breathing, combustion, that is, the most abundant non-metal in Earth crust is oxygen. Nitrogen, reduces the rate of combustion. Sulfur, making acids, fertilizers, explosives, fungicides. Here note that the properties of non-metals are opposite to metals. Non-metals are the elements that do not conduct heat and electricity, and are neither malleable nor ductile. Non-metals are brittle. Examples are carbon, oxygen, hydrogen, nitrogen, chlorine, bromine, etc. General properties for metals and nonmetals are: properties of metals are malleability, ductility, good conductors of heat, good conduction of electricity, lustrous, generally hard, generally strong, generally exist as solid state, melting and boiling points are high density, sonorous, and color. Properties of non-metal are non-malleable, non-ductile, brittle, bad conductor of heat and electricity, non-lustrous, generally soft, not strong, exist in all three states, melting and boiling points are low, low density, non-sonorous, and color. Examples of few metals and non-metals in periodic table. Metals like sodium and magnesium are towards the left-hand side of the periodic table, while the non-metals like sulfur and chlorine are found on the right-hand side. In the middle, we have silicon, which is classified as a semi-metal or metalloid, because it exhibits some properties of both metals and non-metals. Representation of metals, non-metals, metalloids in the modern periodic table. In the modern periodic table, a zigzag line separates metals from non-metals. The borderline elements, boron, silicon, germanium, arsenic, antimony, tellurium, and polonium, are intermediate in properties, and are called metalloids or semi-metals. In the image of the periodic table shown on your screen, the elements touching above part of zigzag line are metalloids. Metals usually have 1, 2, or 3 electrons in valence shell. All metals are solids at room temperature, except mercury. Metals react with acids and bases to form hydrogen gas. Metallic properties of elements decreases across periods. Metallic properties of elements increases as we go down a group.